Okay, we will start the second part of the lecture. We'll focus now on the different systems that can be applied in your project. طبعا selecting the system starts from understanding the components of the project. If you have a high-rise building, a large span, different projects or different elements of the project that has require different systems. You might not use only one system for the whole project. You might have a high-rise building and a podium for a shopping center and another hangar for industry. So you can have different systems at the same time. So you have to select how to select the appropriate system and how to integrate them together in your project. طبعا any space starts with a form, a cube, a cylinder, a sphere, and this form, this is what needs to be covered and protected from the weather outside, and this is what needs to be provided with a structure. طبعا the old type of structure was the bearing wall, and this bearing wall was used for thousands of years using materials like stone, like mud, like even concrete was used, but not reinforced. Concrete is a very old material, but it was not with reinforcement of steel. And from the load-bearing systems, the walls, we started to have elements created by the reinforced concrete. These elements we started to use as arches and vaults. So the arch is a single dimension in elements. We have a vault that is in 2 dimension. It is supported on 2 sides. We can have a shell that is supported from the 2 ends. So we can have arch, which is 1 dimension, vault, which is 2-dimensional, and the shell, which can be in different directions, as we will see. Also, the dome was a type of structure used from the old time using mud or stone or brick that can be shaped into a dome like. In the countries where they have wood, they use trusses, and trusses allowed them, if you, instead of, you have a 6-meter long piece of wood, but you want larger than 10. What do? You cannot have more than 6. So you use a truss. So the truss will allow you to have 4 and 4, 8. So this truss started to allow you to make larger spans and larger volumes. We also have space frames that cover larger areas, and also the folded plates, folded roofs that create a shell that is covering large areas. We all have another type of structural system that does not take the force from up to down. No, it carries the form from top to the columns. So this is called tensile. I'm not carrying the force all the way to the ground. No, I'm pulling it like this, and then I take it to the ground in a different place. So instead of carrying the load to the ground like this, no, it is a tensile structure that carries it from above. Now, this is very useful in stadiums and large areas that can be covered with tensile structure. Again, I can combine more than one system. I can use part of my design with a tensile structure, another part with shell, another part with skeleton. So it depends on what you want. It's not one system for all. I can adapt the system. I can have two systems above each other. I can have skeleton, and above it I have folded or shell or vault or dome or whatever. So the structural system is flexible. Now, as we said, we start with the load-bearing walls to the skeleton. The load-bearing is the oldest type that rarely used nowadays. It was transformed into a skeleton with columns and beams that can be used to transform the loads. Also, in places where they have wood or timber, they can use it as a load bearing. Skeleton transform the system to elements, columns, and beams and floors. And it can cover larger areas. If it's made of steel, it can cover up to 3 meters span. The load-bearing walls is very limited in span. It can cover 5-6 meters maximum, but the skeleton concrete can go up to 20 meters, steel can go up to 30 meters, and also the timber can cover up to the 30 meters. So we start to have large spans. This is the case in your project. You have large spans. You need to use a system that allows you to cover these large spans. The problem is not the load that you carry to the ground. The problem is how to cover the space that you want for the exhibits. Now we start to have arches and vaults and domes. If you make the arch with brick masonry, you can make it like 10 meter span. With reinforced concrete, you can make the arch up to 60 meter span. So it can cover large areas. Timber can go up to 100 meter span. So these are spaces that you might require in your design. If you have holes or spaces that are 30 by 30, you need to think about the system that can cover that. The vaulted roofs can also use to cover the roofs. So don't think about the whole system as one system. I can use the lower 2 floors skeleton, and then the last floor or roof, I can use a different system. And this mix and match between the systems is important. On domes, it's like the mosque. You know, so you have the whole area of the mosque is skeleton type, but the large space in the middle is dome. These are two systems. The frames are also a good system that can go in larger spans. If they are made of steel, they can go from 9 to 60 meters. Laminated timber, 12 to 35. Reinforced concrete, 12 to 24 meters, the frames. And they can take different shapes depending on the function that you want to cover. A factory, a museum, and so forth. Trusses, as I said, they can make larger spans. For the timber, they can span 5 to 11 meters, and the height is 12 to 25. The steel can make cover 25 to 65, and the height can go up to 12 and 75 meters. So these trusses can cover larger spans with few columns. A nice طبعا element or structural system that we use is the space frame or the space truss. Some people call it space truss or space frames. The space frames are very light elements that are connected together, and these connections make them rigid enough to cover larger areas with light materials. And the shapes can take any different pattern or shape that you like. But the problem with the space truss is it's very light. You cannot put any floors on top of it. It's only one end. And you can carry it on columns far from any structure, and they can cover the whole element. So they can be like a ceiling for the whole structures. They are connected with the joint, the ball joint, and all the elements go into that joint. And it can cover airplanes. Most of the airplane hangars are using this type of system. It's very light and covers larger areas. So if you are designing exhibition, auditorium, stadium, this can be a good system. The folded roof is a good concept for construction, especially that when you fold a paper, it becomes stronger. So that the different folds that you use can cover larger spans. You can go spans 20 or more meters. And they can take different forms. So the form is up to you. You are using folded slabs, but what is the shape of the folding? And how is it covering the space that you have? These are also examples of the different folded. The different folds of the structures. And this is very useful in factories because you need to have top lighting. Also in museums, if you need top lighting, you can use this folding, so you can get a northern light through the ceiling. Shells, of course, are very innovative types of structural systems. They use very thin layers of materials, and the strength of the structure is coming from the shell shape, exactly like the egg shell or the seashell. Its strength is coming from this surface. So the design of the shells gives it a strength in different directions, and this can take any form that you need. So you need to think about this as maybe one of you will take it as a whole envelope for the museum, one big shell. Another one will use a small shells for different spaces. Another one will use column and beam in the first two floors and then a shell on the third floor. Or you can have different types of structures in the same building. So the structure system is another dimension of architectural design, because it's not only a solution to carry the building, it is part of the form making in the interior and exterior. We are not requiring you to calculate sizes or dimensions. This is not what the architects need. They need to think conceptually about the structural system. طبعا the shells, they can take different forms and many ideas and buildings are generated using these shell types of forms. The tensile structures are structures that are held above, up, not down. So they have these cables, and these cables, they carry the roof from the top, but you need to have these big supports that take the load to the ground. So this tensile system is very, very creative and creates interesting buildings. There is another type also that combines the tensile with membranes that cover space. So it's not only a one element that is covering one direction. No, between the tensile cables, you can cover with materials. And this is what they use in stadiums and exhibition buildings. The masted structures, these are structures that are suspended from the top and fixed to the ground. So they are taking one shape. These are examples of the masted structures, tensile structures, that are carried from top and fixed to the ground. They create interesting shaded areas. They create significant form for the building. They can be on the last roof, covering the rooftop of the building, not necessarily from the ground. You can use them in upper parts of the building. There are design strategies and guidelines to think about structural materials and the different materials that we use, including steel, reinforced concrete, masonry, timber. These are the basic materials that are used as structural materials. So you might not use reinforced concrete in your design. You might select to use steel. Okay? And have maybe tent structure on top of the steel or space truss. You don't limit yourself to the reinforced concrete only. Think about different materials and metals for the cladding, for the covering of the building. In summary, we have different systems that can be used individually, and they can use in combination with other systems depending on the building type or element. You can have 2 floors with one system, and then the third floor another system. You can have the one half of the building with a system and the other half with another system. So don't limit yourself to the column and beam structural system. It's not appropriate for your type, for project type, for this museum with large spaces. So this is like a summary table for all the materials and how to select from them and use them in the design. I would like to move now to some examples that can bring these concepts closer to your mind and make you understand how can we select the appropriate type of structural system for the project. Structures are very important understanding for architects. The more you will learn about structural systems and be able to control them, the more creative your designs can be. You can make different combinations of systems. You can use them in a new way, a new form, a new shape that you need for your design. So I think at the end of this presentation, Taman discovers all types of structural systems and how they can be used and the spans you can select from. It's a very comprehensive presentation that was made over the years. One of the important elements you might need in this project or future projects is how big is the beam. Suppose I'm using a skeleton system and I want to use large spans. So the beam starts from a simple beam. This can be like 10, 12 meters, 15 meters. We usually estimate the depth of the beam as 1/10 of the span. So if you have a span of 15 meters, then the depth of the beam will probably be 1.5 meters. Okay? If you don't have enough space to have 1.5 meters, then you need to think about another system of construction. After the beam, if we want to have larger spans, 20, 30 meters, then we go to what we call Vierendeel beams. These are large spans beams that can cover large spans without any columns in the middle. And this is called Vierendeel beam. If the beam gets very high to become one floor, 3 meters, then we call it Vierendeel truss. And this is usually a floor that contains mechanical and technical systems. So this is part of the structural systems that you have. When you look at the skyscrapers, you find floors that are closed or has these crosses from the outside. These are Vierendeel floors that contain structural mechanical services. So this is a type of a folded slab. You see the folded slabs, they go all the way to the ground and they cover the whole building from outside. So you have two layers, the layer of the folded plates and the layer of the building inside. So the appearance of the building from the outside is very impressive. The shells are also useful for large areas, parking areas, and so forth. So you can cover this with shells. So the expressions that you get from different systems, you have to think about it as an integrated part of your design, because it's not only structure system to put some columns. No, you have to design the system as a whole and decide which system you're going to use for which part, horizontally or vertically. Okay? So the system that you use will be expressed in your design. If you're using walls, carrying walls, or you're using beams or verandils, if you're using mushroom columns, like Frank Lloyd Wright, wax towers or wax office building. This is a system that he developed, that the column is in the middle of the area and it's going like a mushroom carrying the roof on top. So the system you use is an expression from the outside. In brutalism architecture, you see that the beams and columns are a kind of an expression of what the architect wants. The space truss, as we said, is a very impressive system that gives you large spans that you can use. The tensile, the systems, this is the Dallas Airport. You see the roof is not supported by the column. It is suspended by the column. So the column goes through the roof and it suspends it from top. So the expression is not a column beam. It is a suspended with the same beam. This is Olympics, where they had tried to use the tent structures to cover the whole village facilities. So, and the tent is suspended from the top. Le Corbusier also used innovative structural system to express the chapel or the Ronchamp chapel in France. It's an integration between the shell and the skeleton and the spatial. So it can be innovative as you need. In high-rise buildings, as you see, you have verandil floors. These floors are service floors. They are escape floors that people can go to in cases of fire or damage. This is a suspended our bridge on the Nile is Tahya Masr is suspended by cables from top. So when you look at any structure, you have to think about what is the structural system used here and how is it used and how big does it cover of your design. The steel has its own merits because it gives you small sections and covers large spans. This is Villa Savoye in France by Le Corbusier, where he uses the 5 elements of modern architecture: the piloté, the columns, the open plan, the free plan, the continuous windows, the roof, and the ramps. These are the 5 elements that Le Corbusier considered as the trademark of modern architecture, did not exist in the architecture before. This is his Unité Habitat in Marseille, where he used the modular. You will find a grid, a very clear grid. He uses it in the whole building. And he combines 2 floors together. So the grid is one thing. The module is another, is what is inside the grid. And I can use 2 grids, 4 grids, 3 grids, as I want, modules. And the grid is always there. but depends on what module you are. And this is part of his theory of the modular. Frank Lloyd Wright used to make these prairie houses with this large cantilevers. طبعا his most famous project was the Falling Water, where he used large concrete spans. This is Moshe Safadie's Montreal habitat, where he used the box structure. So the box is a structural element and a functional element. And he combines them on top of each other to create the structure and the design that he needs. So the structural system is an expression. It's part of the form and part of the concept that you have. It's not only to locate columns at corners, خلاص I finished the structural system. No, you have to think about the structure as space and maybe more than one structural system in the project, and so forth. So the expression of your project is supported by the structural system. So far, we were only designing zoning and spaces. Now we need to add the structural element and see how does it reinforce or contradict with your design. So any structure or any project needs a good structural system to express it and let you see it more clear. So all these are examples of how structural systems are used. These are the shells that cover the space that you have. Large spans with big concrete. The dome suspended by the columns. The Frank Gehry's work of multiple layers, the work of the Centre Pompidou, where they expressed the technical systems in the elevation. So it's not only they express the structural system, no, they even exposed the technical systems. And this is Richard Rogers and Renzo Piano. They created this big project, the Centre Pompidou, where the very successful place in Paris. When you think about Sears Towers in Chicago and the Hancock Towers, you see that the structural system, these braces and these tie beams are an important expression of the structure. This tower depends very much on these braces to hold the building together. So any building you look at from outside or inside, there is a structural system employed. And the success of the building is that it makes the structural system positive addition to the project. So here we have frames, here we have space truss, here we have space frames, here we have wood. So the material and how it is employed in the project is not neutral. It changes the project. So this is something we need to think about in our next leader, how the stadium seats are covered by the tent structure and the columns suspending them. So any design you look at, there is a structural system, and the structural system affects this design very much, and sometimes supports, sometimes plays against the. You see here we have the reinforced concrete part covered by a space truss part within the same building. Okay, I think that is the end of the presentation. These examples are just illustrations of how structural systems can affect positively or negatively your design. And you need to select the appropriate system for your project. Okay, and thank you very much. And we